Okay, today we're going to talk about absolute value and their transformation. So, what is the absolute value, right? So, absolute value is just this parent function up here. So, y equals, and then those two lines that are straight outside of the x, that's the absolute value of x. So, we need to figure out what that actually looks like. And so, in order to do that, I can use my graphic calculator, or I can come to Desmos, y equals, and then you can always find absolute value down here. If you click on this keyboard, it's just right there. You click there, and then we throw an X into it, and we go ahead and hit enter. And so this is the absolute value graph. It forms a V shape, okay? If I wanted to, I could grab some points. And so those are the points that I'm going to grab right here. So that's what I'm going to graph by hand over here. So the most important point is at 0, 0. That's my vertex. Okay. So again, I had points here and I had points there. So the vertex is basically where my V meets, so the bottom of the V right here. Sometimes it could be the top, depending on which direction it was, but the vertex is there in red, okay? And so that's the most important point of my absolute value function. So anytime that I'm looking at absolute value, I want to figure out which one the vertex is, okay? So this does have slope. So essentially, these are two linear lines that were connected, right? So I'm going to find the slope really of both of these. So if I go from the vertex, I go up one and right one. So this side to the right of the vertex has a slope that is a positive 1. And if I look at the other side, I went up 1 and left 1. So that tells me that we also have a slope of negative 1. Okay, so we actually have two slopes. And instead of writing it how I wrote it, I can simply just do a plus or minus sign and then the actual slope. Okay, so I'm just going to say the slopes are plus or minus 1. Okay, it'll always be the same value, the same, not necessarily the value, but the same number, and then it's going to be the positive of it and the negative of it. Okay, and so then what we need to look at is the domain and range. Okay, domain again goes left to right. And so if I look at how far left this goes, it goes to negative infinity, how far right to positive infinity. So the domain is going to be all real numbers for this function. And then my range, the lowest value is 0. The high value is positive infinity. We can be or equal to at 0, so we use a bracket. And then the parentheses will always be attached to my infinity sign. Okay, and so this one is considered, like I said, my parent function. This is where it starts. Right, so all other functions that look like this one will originate from here. And so this is where we go back into our transformation rules. So let's go ahead and do the next one. So this time we have y equals x plus 3. Okay, so what I'm going to do is I'm going to look at the transformation that occurred. X plus 3 inside the absolute value symbols is just like inside the parentheses. So this shifted to the left 3 units. Okay, so left 3. So if I took my original equation and I move it 3 places to the left, then all these points are going to start there. There's my vertex. And then I just shifted all those points 3 to the left. Okay, to verify this, right, I can always use Desmos. y equals absolute value of x minus 3. Oops, it was x plus 3. And so it does in fact move to left 3 places. So it's at the vertex is at -3. So really that's the main one I care about. So it's -3 now. And so then again, I write the vertex, -3, 0. It was just shifted left 3. And then again, my domain is still all real numbers. My range, again, goes from 0 to positive infinity. So moving left to right really didn't affect my domain and range. Then I look at my next equation. Okay, transformations first. This tells me that I went down 5 units. Okay, down 5 units. And then what I'm looking at now is, again, I base it off the parent function. So if I take that original vertex at 0, 0, and I move it down 5 places, now that is down here. And I did nothing else but move all those points down. So this is what my graph looks like now. Okay, again, to verify, I can look at Desmos. I can change this, go outside of that, -5, and then indeed you can see that it was just shifted down 5 units. Okay, and so my vertex is at 0, -5. This time the y value, was affected. My domain is still all real numbers. My range now, though, is from -5 to positive infinity. Okay, and again, a bracket on the -5 because it is a solid dot. It can be equal to that lowest value. All right, and then right here, we can look at, again, my transformations. All right, this time I have 2. So I have x -3 tells me I went right 3 units. The +4 tells me I went up 4 units. Okay, so again, if I started at my vertex, here's my original vertex. I went right 3, 1, 2, 3, up 4, 1, 2, 3, 4. So now my new vertex is there. And then I know that I have points that do that. Okay. And so my new vertex is at 3, 4. My domain, still all real numbers. My range is now at 4, can be or equal to, so we use a bracket. Infinity always has a parentheses. Okay, and then this time we have, again, my transformation. This negative right here in front tells me I have a vertical, or sorry, not a vertical, I have a reflection. My bad. So I have a reflection over the x-axis. Okay, just to kind of give you guys an idea of what that looks like. If I put a negative out here in front, boom, you can see it is in fact a reflection. So what does that look like? My vertex is here, still at 0, 0, and now it was reflected downwards. So that's what my graph looks like. My domain, again, all reals. My range, though, has changed to -infinity with the parentheses. And then the highest value is 0. It can be equal to 0, so we use the bracket. Okay, so the low value is -infinity because of these arrows. All right. Next, we have two transformations. The 3 tells us we have a vertical stretch, okay, by 3. And we went right 2 units. Okay, so vertical stretch and right 2 units. So I'm going to go ahead and do this one over here on Desmos. Just put a 3 minus 2. And we can see that the vertex was moved 2 to the right. Okay, but then also what happened is this V shape kind of is growing a lot faster because of the vertical stretch. So the vertex, again, is important. So now the vertex is here at 2, 0. Okay, but I don't have my original points right here because the slope has changed now because of my vertical stretch. So what I need to do is grab a few more points. So I'm going to convert this to a table so that I can see my vertex is 2, 0. And so I'm just going to grab a couple points right there, 1, 3, and 3, 3. So my points have now come to 1, 3, and 3, 3. And so it's gotten steeper slopes. So my slopes are plus or minus, and really I just have to calculate 1. Rise over run, I go 1, 2, 3 down, 1 over, so that's 3 over 1, so plus or minus 3 for my slope. Okay, domain and range. Domain, you guessed it, is all real numbers. My range goes from 0 to positive infinity. Again, bracket with the 0, parentheses with the infinity sign. And then the last one, again, transformations first. We have 2 again. The 1/2 this time tells me I have a vertical compression by 1/2. And then that 2 tells me I go left 2. Okay, again, I'm going to use Desmos. So I'm going to change this equation. Let's just retype it. Y equals absolute value of x. And actually, we had a 1/2. And then I believe it was plus 2. Okay, just double checking. Yes. So now again, it moved left 2, and now it has been compressed, so the graph looks like it's gotten wider. It's gotten flatter slopes, right? So again, I'm going to convert this to a table. This time my slope is at -2. Okay, so I do want some points to the left of that as well. And I'm just looking at whole number points. So I like 0, 1, and -4, 1. And so just remember, it's always it's symmetric, right? So my vertex is at -2, 0. And then remember, it's symmetric. So I had a point at 0, 1. Okay, so it's symmetric about the vertex, right? So if I have that there, I know I have another point over here at -4, 1. Okay, and then again, to find my slopes, it's always going to be plus or minus. And then I go from my vertex up 1 over 2. So my slope is 1/2. Domain, all reals, range, we go from 0 to positive infinity.